Welcome to today's recording. Today we want to look at probability modeling. Under this probability modeling, we want to look at something by the name generating function. Generating function, let's just consider a sequence of real numbers. For example, we have A0, A1, A2, A3 all the way to infinity. A function A of S given as A0 plus A1s plus A2s squared plus A3s cubed plus all the way is equal to the summation of ak s power k, where k lies from between 0 to infinity. Therefore, a function is called a generating function for a given sequence if it exists bracket convergent for some value of s. I hope you're getting me right. Where we're getting this is that we are considering a sequence of real numbers. Those real numbers are A0, A1, A2, A3 all the way. Then now we are now considering a function A of S. Where A of S, what we are just introducing is the S in the real numbers sequence we had. A of S is given as A0 plus A1s plus A2s squared plus A3s cubed plus all the way is equal to the summation of ak s power k, where k lies between 0 to infinity. Therefore, what you should need to understand here is a function is called generating function for a given sequence if it exists for some value of x. Thank you. As we continue, let us check on an example. An example is here. 1 minus s in bracket times 1 plus s squared plus s power 3 is equal to 1 minus s plus s minus s squared plus s squared minus s cubed plus s cubed minus s power 4. What you've just done is this. You've taken 1 times that 1 minus s plus 1s times 1 minus s squared times 1 minus s cubed times 1 minus s has given us all these things. Where we now will end up and say 1 minus s plus s minus s squared plus s squared minus s power 3 plus s power 3 minus s power 4 if you do that. So minus s plus s gives us a 0. Minus s squared plus s squared also give us a 0. Minus s cubed plus s cubed also give us a 0. So our final results we get here is 1 minus s power 4. Therefore, when we divide both sides by 1 minus s, this side and this side, we get 1 plus s squared plus s cubed is equal to 1 minus s power 4 over 1 minus s. I think that is going home now. Just simply dividing, general division, put over. Because the answer we've got on the other side is 1 minus s power 4. But we had our previous expression that 1 minus s times 1 plus s squared plus s power 3 would have given us 1 minus s power 4. Then you divide both sides by 1 minus s, you end up with that result. Then a of s is equal to a0 plus a1s plus a2s squared plus a3s cubed, where a0, a1, a2, 3 is equal to 1, 1, 1. This implies that 1 minus s power 4 over 1 minus s is the generating function of 1, 1, 1, 1. Therefore, 1 minus s power n over 1 minus s is the generating function of the sequence 1, 1, 1 all the way in terms of 1 plus s squared plus s squared plus s cubed plus all the way to s power n minus 1. We don't stop there. The limit of 1 plus s squared plus s power 3 plus all the way to plus s power n minus 1 is equal to the limit of 1 minus s power n over 1 minus s, where we take the absolute value of s to be less than 1 as n tends to infinity. Get that 1 minus the limit of s power n implies that s power n approaches 0 as n tends to infinity. There, in the absolute value of s being less than 1, that means it's a fraction or a decimal. So the higher the power of a decimal, that will lead to the decimal depreciating and become smaller value. So that means as s power n goes to infinity, as n approaches infinity, then s power n approaches 0. The limit of 1 plus s power n, limit of 1 plus s squared plus s cubed plus all the way to plus s power n is equal to 1 over s, where we'll have that 1 minus, which is equal to 1 minus s power negative 1. That's just the reciprocal, the one you know. 1 over 1 minus s is the generating function of the sequence 1, 1, 1. And that's the work done. That's now how to prove that the generating function of the sequence 1, 1, 1 is 1 over 1 minus s. Thank you. And don't leave without subscribing to our YouTube channel. Mathematical Solution is the home. Thank you.